Hi, I'm Paco Nathan from O'Reilly Media, and it's a pleasure to have Adam Gibson from Skymind here.
Good to be here, Paco.
Welcome.
Thanks.
So I'm curious about what you're seeing in terms of industry, some of the pitfalls maybe of deploying machine learning in production.
Right. Well, so a lot of it comes down to data scientists, despite being very smart people, are at the end of the day are very focused on just experimenting.
Huh.
There's a lot of enterprises still trying to hire for actual line of business.
Okay.
And they're advocating for that more in the education, but ultimately a lot of data scientists are still focused on a lot of hype.
Right.
So they're jumping on the latest thing without understanding, can logistic regression work? Can linear regression work? What's the simplest model I could deploy? And they're also not thinking about maintaining models.
Ah.
They're just thinking about continuous experimentation
But not like the life cycle.
Yeah, exactly. They're not thinking about the whole model life cycle. Like, what happens after I hand this off to production?
Okay.
What happens in production? They're not really asking those questions. And sometimes it's just limits of their job. Sometimes they have big enough teams where they don't have to worry about that.
Sure.
But ultimately, the data scientist has a lot more responsibility now because they can affect the data collection process.
Right.
There might be a lot of complaints around features that they might be missing, but maybe they don't have enough time to ask about it. And there's also
like bias being introduced.
Right.
For instance.
Bias. Yes. Bias. Could just be misspecified fields.
Yeah.
Could just be they might just not be signaling to management that why does this data take 3 months for me to acquire? So that's a big bottleneck. And so a lot of and then they also might be missing compliance requirements.
Wow.
Are we hitting are we complying with all laws around privacy? Is the right auditing in place? How do I know who else is accessing this data?
Right.
A lot of the times IT will have those questions, and the data scientists will just instead try to work against or around those people. So it's really hard for organizations to collaborate. So it's largely a people problem.
So what kind of tools and techniques can you bring to bear on this?
Well, so a lot of so it's kind of a cheesy buzzword, but data governance.
Okay.
So really having automated auditing, so the data scientists don't have to think about it. So tools like NiFi, Apache NiFi, and StreamSets are doing this, where you're monitoring end-to-end data pipelines. I think this is going to become more of a growing trend over time.
Okay.
So things that the tooling just needs to get better around this. And so we're at the early stages of this, but I think ultimately if we're going to build an ultimate kind of experiment haven for data scientists to where they can comply with all requirements, better collaborate with developers, like deploying models to production, for example, I think we're going to need I think we're going to see a big shift towards a portal approach to AI. So you're going to see Facebook has FB Learner, Google has some of their internal infrastructure, and so there's this big focus on hubs being created. So for example, Amazon SageMaker, you'll see tools like that evolve into a hub, and that's actually what we built at Skymind as well.
Interesting. Now, out of enterprise, say like you're at a bank or you're at a telco, who's really driving a lot of that kind of data governance? Is it coming solely from IT, or is it more coming from a higher level like
there's all this buzz around hiring a chief data officer or chief information officer.
Yeah.
They are the ones really driving a lot of those trends, I think, and because they're starting to see for example, Europe is becoming more tightly regulated. You have Facebook being kind of hit for privacy violations and things of that nature. We're starting to see that come up more and more, and I think some people are being more proactive about making sure that they're kind of complying with all laws and having a lot of infrastructure in place so they don't get hit with these penalties.
Gotcha. Yeah, risk is bubbling up to the top.
Exactly. Yeah.
Interesting. So, are there ways of using? I think one of the quotes from the keynotes today was about using machine learning to monitor machine learning. I mean, there's techniques we can do in machine learning to help this.
Right, and so active learning is one of those areas.
Okay. Break that down a little bit.
So active learning is where you ultimately have humans in the loop trying to kind of auditing what the machine learning models are doing. Because ultimately, machine learning models come down to you have a softmax distribution in the end. Right, you have a 0-1, you have a probability of something happening, right? And so that means there's room for error. Right. But ultimately, you have rules engines being deployed, that's kind of the 1950s era machine, AI. But we're still seeing that applied today because at least it's deterministic, and deterministic and being reproducibility and even interpretability is that's a big area of focus now. Right. So active learning is a kind of a bridge to that, where we can use kind of riskier models. But we can actually monitor it and keep an eye on it.
So the higher parts of risk coming out of a model then can be deferred to the human?
Yes.
Is that?
Yeah, so we have a lot of things where the model decisions with a low confidence interval being kind of kicked to humans.
Oh, excellent. I've never heard of that described as far as a kind of risk mitigation, but that makes all kinds of sense. I mean, the general category, we're talking about uncertainty, systems that work with uncertainty.
Yes.
But I think that sometimes the real performance metric you're worried about is risk.
Right.
So maybe we can consider risk to even be a higher value than just uncertainty in general.
Exactly. Well, and if you think about it, rock curves also play into this, rock curves and decision boundaries.
Yeah.
Right. Where we're retuning precision and recall for essentially what is risk. Right. And so if you combine that with humans in the loop, all of a sudden you have a pretty tightly controlled system that you can tune over time. And so, I think tooling will evolve around that will allow us to say, monitor our decision boundary over time and watch for, maybe attach a risk score to that.
Yeah.
And with that kind of monitoring and then a human auditor built into it, you can automate things you normally couldn't before, while also being able to say to your stakeholders that you're deploying this safely and here's how.
But that really underscores that there is a human in this interface,
Exactly.
in this whole equation. So when it comes to auditing, when it comes to interpretability, it's already built in.
Exactly. Well, and so because if you want to apply like a newer tool like deep learning, for example, you don't have that interpretability. I mean, there's a lot of one of my colleagues, Dave Cal, actually does machine learning. He runs a machine learning for healthcare conference in LA. And so this was a conference that was held earlier this year, and one big theme that came out of that was that there's a lot of research only in healthcare and deep learning around interpretability of the models.
Ah, interesting.
So this is an emerging area, but ultimately a lot of that research isn't going to be applicable until 5 years from now. Yeah. There's a lot of room yet for before productionizing this. So the compromise is kicking off the final decision to a human when you're uncertain.
Do you have some customer use cases?
Yes.
Excellent.
Yeah, so a lot of that, so one of our biggest customers is a gigantic telecom in Asia, and we're actually helping them with, we're augmenting them with deep learning to basically, we have their analysts use deep learning to figure out with some manual observation to both label data as well as find causation in faults in the network, among other things. And so so they have so imagine you break up the whole world into 500 meter squares, and what you're able to do in those 500 meter squares is overfit a model. Okay. You overfit that model, and then you have a human analyst using deep learning to surface insights from that. And so what do I mean by that? I mean each 500 meter square is scored and ranked for problems by the machine, and then the human can then take a look at it and improve it.
So by overfitting, then are you kicking out some of the
anomalies?
Okay,
and you do that on purpose, because you want to find root causes and you want to find weird behavior. Excellent. So that's actually the goal.
And that goes directly back to what you were saying before. You want to identify the high risk,
right? And
those by definition are
right. And so that's probably one of the few areas where overfitting actually makes sense.
Excellent. Okay, so I have a question. We talk a lot about supervised machine learning, kind of the devil that's what most of what people are talking about. Deep learning is typically more supervised. There's labels. Active learning is a kind of semi-supervised,
right.
But there's this whole other realm of unsupervised learning, and I haven't seen a lot. I know it's still kind of in research stages,
right.
But what are you seeing as far as like unsupervised learning and deep learning?
Well, for one, don't use GANs.
Okay.
Don't use GANs ever.
Really?
They're too. So most of the research right now is still around stabilizing them. Using them in production is actually a very bad idea. What you should use instead are variational autoencoders.
Okay.
Because they're more stable and they're easier to scale and train, and they give you priors to mess around with. So they give you a lot of, so you can actually tune, very similar to restricted Boltzmann machines. They give you a distribution upon which you can constrain the data. And so you can customize the input and the output. And there's also another paper that came out recently that called the Info VAE, the Info Variational Autoencoder, that actually factors in information gain into the reconstruction error.
Oh, interesting. So now you could have like a gradient of what the different factors are.
Yes, exactly. And so there's a lot of areas for interpretability. I think with a little bit of human, human tooling, human plus some tooling in there, I think you can actually make use of that in real products being deployed. And so if you use that as a way of kind of grouping and finding automatically finding trends in data,
Right.
You know, maybe variational autoencoders plus some sort of, you know, like in this case, we use a lot of T-stochastic neighbor embedding to find anomalies and group, you know, hidden trends and group by automatically grouping data.
For visualization?
Yeah.
Or for
yeah. So for visualization as well as ranking by reconstruction error to figure out of individual examples to figure out what you should be looking at. So there's a whole area where you can use a combination of k-means, VP trees for k-nearest neighbors, reconstruction scores, and t-SNE. There's a whole set of solutions and a whole new workflow where you can kind of bake that into your exploratory data analysis process.
Interesting.
And then you can also you can use it both in your visualizing and exploration process and as well as for monitoring and production.
Oh, really? On the back end?
Yeah. Well, yeah. So what you do is as you get new examples in, you can actually track a reconstruction, you know, moving average of the reconstruction errors very simply to send alerts. Like when it gets above a certain tunable trend,
threshold, yeah.
then you can proactively find new anomalies. So another application where we're using this is actually risk scoring of individual loan applicants.
Oh, interesting. Mm-hmm. As opposed to using a scorecard.
Yeah, exactly.
They've been doing for 30 years.
Yeah, so instead you can explain it and justify it, but you use deep learning to find the trends.
Interesting.
And then so it basically gives analysts at these big companies a tracking beacon on what it allows them to not only increase their hits on things like fraud, you know, finding fraud, but also on identifying sources of risk. As well as causation, root causes in network failure.
Yeah. You know, I'm curious. One of the questions that I've heard a few times is how could we go from a system working with machine learning uncertainty, applying deep learning, but then perhaps at the end of the workflow coming out with rules to encapsulate most of it. Are you?
Yeah. So another thing we do is we use it to create new rules.
Okay.
So it's actually deep learning baked into a rules engine.
Perfect.
And so it's an undeterministic flow that's watched, and then you use that as a way of saying, you know, so send machine learning score greater than 80%, do something, or like record this, or you can just use it to update. You know, you can have something in production that you use it to find new rules to add to an existing rules engine. So you get the weakness of rules engines is that they're not dynamic. Yeah. Well, this gives the people building and maintaining rules for things like banks the ability to proactively identify new trends to add to the rules engine.
Oh, fantastic! And also, I can imagine I'm trying to think as you're describing this. You know, how much code would I have to go through in terms of APIs to implement this? But can you give me kind of like a ballpark figure? Are we talking about thousands of lines of code, or is this something that's is relatively simple to use APIs?
Well, so this is something I think if you have the proper on-prem on-prem infrastructure already in place with things like auditing, I think a lot of it comes down to more training people. Because it's very straightforward to implement things like a feedback API where you can flag this is wrong and then you record that in a database.
Okay.
So it's not rocket science to implement. It's hard to do right, but I think with enough time and enough effort, you can pull this off.
Fantastic. Well, thank you very much, Adam.
Yeah, this was great.
Appreciate it.
Thanks, Paco.
Thanks.